Hello, and welcome to Crops and Carbon, Agriculture and Climate Change Demystified. My name is Josh Lappin.
And I am Emma Hutchinson. We are the co-leaders of the Climate and Energy subgroup of Students for a Sustainable Stanford. We are grateful to be hosting this event with Stanford School of Earth Sciences.
We're so excited to have you all here today, and we're honored to welcome two outside experts in industry and farming and three Stanford professors to discuss the interplay between agriculture and climate change.
We would first like to introduce our moderator. Pam Matson is the Chester Naramore Dean of the School of Earth Sciences and the Richard and Rhoda Goldman Professor of Environmental Studies and a Senior Fellow at the Woods Institute for the Environment.
Her research addresses a range of environmental and sustainability issues, including the sustainability of agricultural systems, the vulnerability of particular people and places to climate change, the consequences of tropical deforestation, and the environmental consequences of global change in nitrogen and carbon cycles.
Dr. Matson is the author of numerous scientific publications and books, including the National Research Council volume titled Our Common Journey, A Transition Towards Sustainability, and Seeds of Sustainability, Lessons from the Birthplace of the Green Revolution. Please welcome Pam Matson.
Well, thank you very much. Thank you, Emma and Josh, for putting this panel discussion together. Thank you all for being here to engage in it. Our intention is that we have lots of time for interaction, Q&A, discussion with all of you. So thank you so much for being part of this, and thanks to Students for a Sustainable Stanford for sponsoring it. So, climate change, a lot of people think about as this environmental issue that we might need to worry about at some point. But many of us recognize climate change as a sustainability challenge that we're already dealing with and that future generations are going to have to deal with in major ways. Climate change is a sustainability problem because it intersects with our efforts to meet the needs of people. It intersects with the well-being of people today and in future generations. And in this particular conversation, we're talking about our well-being related to the ability to feed people, to provide food and nutrition for all of the people on the planet today and in the future. So we're talking about a really huge sustainability challenge, and there's a lot going on at that intersection of climate and climate change and food and agricultural production. And we have a fantastic panel today to talk about that. There's a lot going on the research end. Many people at Stanford are engaged in research to both understand what the problem is and to begin to try to figure out what to do about it and to contribute knowledge to problem solving and to decision making. But there are many in the decision-making community who are out there on the ground actually working every day trying to deal with this, who also are innovative and have important things to say. And so the nice thing about this panel, and again, kudos to the organizers, Emma and Josh, is that it connects from knowledge to action. And each one of our speakers has the ability to reflect on all ends of that, or both ends of that gradient. But we'll start now by introducing each one of them and inviting them just to say a few words, maybe up to 4 minutes or so of their thoughts about what's really important, what they want you all to know about, and then we'll open it up for Q&A and discussion among all of us. So let me start with the introduction of David Lobel. David's down there on the end of the panel. David is an associate professor of environmental earth system science and senior fellow in the Freeman Spogli Institute and a senior fellow in the Woods Institute for the Environment. David's work has explored the links and relationships between crops, crop growth, crop yield, and climate change at local to global scales using some pretty exciting new approaches. And so, David, I want to turn it over to you first and ask you, given what you've been studying, given the experience of your research, what are the things that are bothering you most right now? What should we be worried most about, and what do you think needs to be done at this critical intersection of food and climate? I didn't tell him he
I
was
thought
going
we were gonna
first.
start over there. Let's see, what do I worry about most? You know, I think there's a couple of kind of layers of challenges with climate change. There's one, I think, is just the communication challenge. So oftentimes I worry about just how to communicate this stuff, because it is, you know, it's a topic that's very charged, and there's lots of people really with strong opinions. But the fact is that the answers are not always so clear cut. It's not as simple to say that climate change is bad for food production or bad for food security. There are definitely positive aspects. There are places that'll actually gain. But that doesn't take away from the fact that it is a huge challenge. In most places, the net effects are actually negative. So a lot of my worries, and this is also the past year being in the IPCC and trying to actually sit up in a room front of 250 delegates from around the world and trying to explain very precisely what we know, and they want to push you in either direction. And it's very hard to actually communicate this without trying to downplay the importance of it, because it is important, but it doesn't mean it's a very simple solution. So beyond the communication, I think what we're actually kind of working on or worried about is trying to evaluate solutions. So I think, you know, over the years, this is going to make me sound like the old guy in the panel, but I just realized I am the old guy in the panel. So somehow that happened. I don't know. I think 10 years ago there were legitimate questions about, is this an issue that we should really pay attention to? And I think, you know, now we're more at the point of understanding that yes, it is an important issue, but what specifically should we be doing about it? And that's a hard question, and it's we're down to the point of, I think, on a region and crop specific kind of basis, trying to develop the tools to really evaluate what is going to work, how effective is it going to be worth really changing how we do things like developing crops or managing systems, or should we put our efforts elsewhere, either when we're thinking about adapting to climate change or when we're thinking about reducing emissions. And you know, those are the kind of issues we still grapple with. I teach a course in the spring for those of you who are looking for courses to register for. Eli is actually an alum of the last time I taught it, so see what happens when you take it. But yeah, I mean, we'll have plenty of time for questions, but those are just things on my mind, I guess.
Okay, perfect, great, thank you very much. Okay, let me come to the other end of the table, to Marshall Burke. Marshall is an assistant professor in the Department of Earth System Science, a center fellow in the Center for Food Security and the Environment. By the way, I forgot to say that David Lobel is the associate director of that Center for Food Security and the Environment in the Freeman Spogli Institute and the Woods Institute for the Environment. So Marshall actually just joined us this year, and he is also working as a sort of a center fellow in the Stanford Institute for Economic Policy Research. He's an economist. Now, Marshall, among other things, a lot of the focus of your research has been on this intersection between climate change and conflict. And, you know, what are the key take-home messages of that analysis for food and agriculture? And how do you connect those things?
Thanks, Pam. Great question. So this is a panel, I guess, and an event about climate change in agriculture. And as David mentioned, I think we do now have a lot of good evidence sort of characterizing, understanding the risks that a changing climate might pose for agriculture. In particular, people have studied this pretty well, David, and other folks on the panel. So we have a good sense of sort of in agriculture, or a growing sense in agriculture of what might happen if we sort of don't do anything under a business as usual sort of scenario. We know a lot less about climate risks for other parts of the economy, and so that's one of the things I've been working on lately. And what we see, and kind of the way you study this is you start by looking historically, or one way to study this is you start by looking historically and look at how things you care about, things like overall economic performance or civil conflict, which Pam just mentioned, how these things respond to historical changes in climate, right? And what we see when we do that, we see that agriculture responds, so David mentioned this, and a rule of thumb there is historically in the US and places like sub-Saharan Africa, for every 1 degree Celsius increase in temperature, agricultural yields decline by about 10%. Okay, so that's agriculture. We start looking outside agriculture, so let's take the case of civil conflict. So We know there have been lots of civil conflicts and civil wars in sub-Saharan Africa over the last 20 to 30 years. We have a lot of data on these right now, actually pretty good data on where and when these happened, and we can do a similar analysis, look at how these things respond to past changes in temperature. What we find when we do that is an even larger effect. So about a 20% increase in these large-scale civil conflicts per 1 degree Celsius increase in temperature. So what's going on there, right? That effect seems huge and sort of hard to believe. So we don't really know yet. This is something we're trying to understand. Part of the effect is almost certainly through agriculture. So we know that you know, most people joining these rebellions were farmers to begin with. So if they had a bad year in farming, maybe that makes them more likely to join these rebellions. But there also might be sort of non-agricultural reasons that these things flare up. And I think, as Pam alluded to in her question, I think we really need to understand how these sort of, you know, if we care about agriculture in particular, or food security or hunger, you can sort of call it what you will. If we care about these outcomes, we need to understand how these sort of non-agricultural effects of climate change might feed back into the agricultural system. And from a research perspective, I think our understanding of that right now is pretty poor. But what we do know suggests that these feedbacks could be pretty large and not all that helpful.
Well, you make a great point. The feedbacks are the things that lead to the big surprises, and they're really hard to understand in this complicated system. Okay, thanks, Marshall. Okay, Anna. I'm going to go to Anna Michalak next. Anna is a scientist in the Department of Global Ecology at the Carnegie Institution of Washington, right down the street here on Panama Street, and she is also an associate professor by courtesy in the Department of Earth System Science with us. Anna works on biosphere-atmosphere interactions. There's fascinating ways that changes on the land surface affect the atmosphere, changes in water surfaces affect the atmosphere, and vice versa, this interacting system. And a lot of her recent work has been focused on climate impacts in watersheds and at relatively large scales, regional scales on the land surface. And with a focus on impacts on water quality, but also focus on impacts on the land systems themselves. So, Anna, tell us a little bit about that research. You're looking at a relatively coarse scale when you do this. What are the messages you take home from the research about then what it means for agriculture?
Right. Thanks, Pam. So, as Pam mentioned, there's two ways in which our research really intersects with the topic of the panel here. The first is to really understand what drives net carbon uptake or release at the land surface, including in ag lands. But the other one, which I think may be a little bit more interesting for discussion today, is the one that Pam alluded to as well, which is the link between agriculture and water quality and climate. We're used to thinking about agriculture, of course, in terms of water quantity. How much water do we need, and where does that water end up in the end? But along the world's coastlines, what we're seeing are huge impacts from nutrient loading coming from human activity, primarily agriculture, on water quality. So things like dead zones, things like harmful algal blooms. To give you two examples from the US, every year in the Gulf of Mexico, there's a dead zone the size of Massachusetts that forms. Give you a second example, harmful algal bloom in Lake Erie just last summer shut down the Toledo water supply for 3 days. People had to get their water elsewhere. And whenever I'm contacted by the media to talk about this relationship between ag and climate and water quality, there's this tendency to vilify ag. So, you know, evil farmers putting all this excess nutrients on the soil, flushing it into our waterways and causing all these impacts. And I think that's a bit of a false dichotomy, because at the core of it, farmers are no more interested in fertilizing the coastal waterways than environmentalists are interested in seeing them fertilized. And so really what we need is a better systems understanding of how climate and land use and water resources interact to yield the impacts that we see. And specific for this panel, meteorology on a year-to-year basis has as much impact on the magnitude of the dead zones, the harmful algal blooms, as does the nutrient loading. So to give you one quick example of that, if I take just 2 years, 2011, 2012, in 2011, in the Midwest region, we saw huge springtime extreme precipitation events, and then we saw the largest ever harmful algal bloom in Lake Erie's history. The very next year, you might remember, we had a huge drought across the US, And we actually saw a very small bloom, but the largest ever dead zone in over 35 years of monitoring. So you're seeing very clearly this link between climate extremes and water quality impacts. And all the discussion, rightfully so, is centered around nutrient loading. How can we manage our lands better to minimize these impacts? But the reality is that we're doing this within the context of a system that is itself changing. So unless we take that into account, we might not ultimately get the bang for the buck that we're hoping to achieve by changing land management practices, because the climate system is changing as well. And I just want to close with maybe one or two examples of how this can lead us astray. You may have heard that there's been quite a shift in agriculture from traditional tillage to either no-till practices or conservation tillage. And this was driven by very valid environmental concerns, reducing erosion, for example. But as a side effect of that, fertilizer tends to remain on the surface of the soil, and therefore when it rains, it gets flushed into water, even more so than under traditional tillage practices. So what this says to me and to others working in this area is that we can't be looking at these problems as a one-of solution for a one-of problem. It's really only by looking at land management, water resources, and climate as a complex system that we can start to work in concert towards solutions that ultimately meet our food needs, meet the livelihood needs of the agricultural communities, but at the same time improve the impacts on water quality, which then have their own downstream impacts on things like fisheries, which are another key component of the food system.
Okay, great, thank you. So we've got a very complex system and complex interactions going on. You can see a number of scientists here trying to figure them out, figure out what's going on, how would we understand that, and then how do we use that information to actually help growers, decision makers, farmers respond effectively to the challenges. So let's move on to Eli, who will hopefully help us will give us a sense of what decision makers, what tools decision makers are beginning to have in order to address these things. So Eli Pollock is a program manager for the Climate Corporation, I think senior program manager. He is one of our own alums from the Department of Civil and Environmental Engineering, Atmosphere and Energy program. And he has worked in a number of different areas in technology, and in solar cells, for example. But in his current role in Climate Corp, we can learn a little bit more from Eli about exactly how he's using the knowledge that he gained at Stanford and other places to help build the technologies that actually would make sense for decision makers to make good decisions in response to the challenges of climate change. So Eli, over to you. Let us know, tell us a little bit about that.
Well, it's awesome to be here. Once I get over the embarrassment of being on the panel instead of in the audience,
Yeah.
I'll have some insights to share. A little background on what we do at Climate. So started as a very small, startup technology company in San Francisco several years ago, and we've now grown to more than 700 folks. And our core mission is to help more or less farmers manage risk from the weather and adapt to climate change. And so the real way in which we do that is today we provide software tools to farmers that help them make decisions based on recommendations for their specific fields and the specific weather conditions in that season, so that rather than needing to rely on best practices formulated for an entire region or the weather that generally happens in their region of the world, they can get a recommendation for example, as Anna was talking about, how much nitrogen is my field really going to need this year? For this year, based on the rainfall that we've seen and the uptake from the plant, rather than just what farmers often do, which is dump so much nitrogen onto the soil that they don't have to worry about it, and a lot of it runs down the Mississippi River, to things like what seed should I be planting. And so we've had some awesome success. The company's grown. Last year, our product was used on somewhere around 50 million acres across the U.S. Corn Belt. And so it's been cool, but I think that when I think about the real challenges and opportunities for sort of commercial technology to help farmers manage risk from climate change, I think the real commercial but also most interesting opportunities actually outside the Corn Belt and outside the U.S. I think that when you look at your average U.S. farmer, these are the folks probably in the history of the world with the best access to insurance, best access to capital, best access to technology. I mean, in many ways, for the average U.S. farmer, the future is here. They've got tractors controlled by GPS. The tractors feed data back off into the cloud. The models can process that data, beam it right back down to the tractor. I mean, from just a technology perspective, the platform on which to sort of play is incredible and interesting. But these are also the folks that are probably, in many cases, the least vulnerable to the real impacts from climate change, and so they may not be feeling the pain quite as much. And so I think that the real question is, how do we take sort of a lot of the technology like we've come to build at Climate and make it available in a way that works for, say, the billion smallholder farmers outside the US, who are the folks that are going to be the most vulnerable to changes in the climate. And I think the thing that makes that tricky is that these are really hard problems. I think when we first started at Climate, we were pretty naive. We were a group of mostly statisticians who thought that if we had enough data, that modeling all of these agricultural systems might be pretty easy. And we were completely wrong. Statistics is, our tool of choice, and it's the most powerful tool that we use to solve all these systems, but the amount that we've needed to learn, Chris in the audience was actually at something like 65, the first employee at Climate who actually knew anything about farming. Maybe that's a bit of an exaggeration, but you really have to know an incredible amount about what's actually going on the ground in terms of the way the plant's using the water, the quality of the soil, and particularly outside the US, in many situations, although it's starting to change with access to microsatellite imagery, other stuff that just doesn't exist. And so you have this combination of the greatest need for a lot of this technology combined with even more challenging problems outside the US and not as readily available opportunities for profit to drive the sort of investment that's actually required to solve all these problems. So I think that when I think about how we should be evaluating sort of the private sector on the contribution to helping farmers manage climate change, is how well can we find a way to develop technology that not only helps farmers in the United States, because that's incredibly important, but really helps bring some of the technology that's going to help people manage changes in the weather and in the climate outside the US. So it's something that I'm really interested in.
Great, thank you. Okay, so this is interesting because we have, a group of academics who study these things, try to figure out reasonable approaches to figure out what the problem is in these complicated systems and some reasonable approaches to be taking. We have Eli talking about really building the technology that would connect that knowledge about how these complex systems work to what the decision makers on the ground need. And now we also have on our panel Jared Lawson, who is one of those decision makers. He is the co-founder and co-director of Pie Ranch. I don't know if you guys have been to Pie Ranch or seen it as you've driven down the coast, but it's a wonderful and very famous farm. And you will no doubt interact with it over the years, because I know Pie Ranch is beginning to be strongly connected with Stanford Dining. And Jared can tell you a little bit about that. But Jared, so Pie Ranch is really focused on the development of healthy local food systems and making sure that people have access to that, and also education. So you're learning on the ground and also feeding it back into the education and hopefully the research community as well. It's a two-way flow of information here. Tell us a little bit about what that's like, where you came from, how you got to Pie Ranch in a sense, and then what you hope for that organization to do.
Oh, wow.
In 4 minutes or less.
Thank you, Pam. And yeah, really great question. And it might consume all of my 4 minutes answering that question and not what I had prepared, but in a way,
Okay, you can have
it's
5.
a good one. Okay. So I'll take the first minute to answer the question of where I came from. So I grew up in that wonderful little basin down in Southern California that also suffered from the impact of human engagement or lack of understanding of carbon in the atmosphere. That's Los Angeles. So I grew up in the thick of smog and moved north gratefully to attend the university just over the hill in Santa Cruz, and was a community studies major interested in addressing community level problems and looking at the theoretical implications of practice and the practical implications of theory, and really kind of driving towards solutions. So using halls like this and campuses like this to really solve problems that we face as a people. And that crystallized in utilizing food as an organizing principle when I got the opportunity to plant my first pumpkin seed on a farm that a friend of mine was apprenticing on in Northern California. And so I was 19, and he brought this pumpkin back to me in the fall from that work, and something like, well, one, I just had this incredible experience that week that I spent on the farm. And this was a farm that, Live Power Community Farm. It was the first community-supported agriculture farm in the state of California. And a tremendous example of not having any negative, side effects of the food production with the soil, with the water quality, with atmosphere, with nutrition, all the dimensions of social, economic, even political linkages you can make back to this farm kind of exemplified to me that move towards a more healthy and just food system that we feel would be better than the one that we currently have. So that's a longer way of getting at what I was hoping to also talk about, which is kind of 5 main points. The first being that indeed agriculture is going to suffer greatly from climate change. There may be some, we may be able to start growing cacao and make chocolate at some point over here on the coast, or grow bananas if some other potential benefits. But by and large, global climatic destabilization is going to negatively impact the way that we grow food, especially if you're relying on chill hours or other historically more stable components that make up viable farming systems. So like I know there's been reports out of Stanford about and UC Davis about the impacts of climate change on just the wine industry in California and grape growing, and how the number of the varietals are just going to not be farmable after 20, 30 years from now. So there's definitely an impact from climate on agriculture. The second point I want to make is that agriculture is one of the principal problems associated with climate change, or the causation of increased atmospheric carbon. And so ag is partly to blame, and can be, I would say it could be part of the villains of the story. And so we do have a responsibility to look at how agriculture could be changed or evolve towards a system that actually is either neutral or a positive contributor to the solution. And towards the neutral, my third point is that organic farming is a step in the right direction, but only at best is kind of a neutral impact on climate change. Currently, like if you're a row crop organic farmer and you put cover crops in the winter, and you're thinking about building soil to sustain the fertility that the crops need to provide good nourishment, you're at best kind of keeping your organic matter, the percentage in your soil, somewhat stable. Rodale has done like longitudinal studies, UC Davis as well, 23-year, 26-year, very long-term studies comparing conventional versus organic, and they've seen the organic matter go up on the organically managed soils, but not much, just a tiny bit. And so my fourth point is that we need to look at solutions that really drive more climate-friendly farming practices, better carbon management, better soil building that can take us from just neutral impact to something that ag can actually contribute to carbon sequestration and help pull some of that atmospheric carbon and store it more meaningfully in the soil. And the fifth point I want to make is that Stanford is part of the solution as well, and in our efforts to kind of begin to model some of these climate-friendly farming practices, which I can share a little bit more of what we are coming into understanding as a real meaningful way of seeing that increased organic matter building of the soil. is that we've recently developed, as Pam mentioned, a partnership with Stanford Dining. So if you're participating in the meal program and you're eating some of the crops that are coming from our farm, you're acting as a commercial contributor to the success of our studies. But then you could also be a part of the academic side of what we want to understand as well, and that while we have these goals, we still don't have the kind of data and fully, there's so much research potential basically to be done on the systems that we're working on, and or engineering, innovations around tools that we could use. That I could spend another 4 minutes describing some projects that I would love to do on the farm that would help us in our farming practices. So between the academic side of Stanford and to the culinary side of Stanford, there's tremendous potential for us as a community to work towards these solutions that will mitigate the effects of climate change in our food system.
Yeah, great, thank you. I have to add in there, I think you probably all know that we now have a Stanford Educational Farm, and hopefully it will be a great partner and linker between all of those, and certainly a partner with Pie Ranch. So I know that you guys all have some questions. I want to follow up on one thing just before I turn it over to you, so get your questions ready. But Jared talked about some of the management approaches that we can do to improve sort of soil quality or organic matter content in agricultural systems, with benefits both in that they reduces the carbon emissions to the atmosphere, also probably allows them to be more responsive to climate-related drought and things like that, more resilient. So there's lots of really cool things that are being discussed and studied and tried. But there's also some work that's being done much more sort of at the global scale, asking the question, how do we build more resilient crop types? How do we reduce vulnerability? And David, I know you have been an advisor to the Gates Foundation on questions like that. Do you have any comments on what you think needs to be done, or what they think needs to be done from the sort of top down to increase resilience to climate change?
Yeah, I mean, everybody has their theories. I think the most general lesson out there is that you don't want to extrapolate too far beyond your own experience, and that happens a lot, especially in terms of things like no-till will work really great in some systems, but as a global solution, there's lots of controversy about how effective it is. Seeds are kind of uncontroversial historically in that they've been really successful. It's very simple to kind of substitute one seed out for another. So the uptake is generally high if the seed is good. But I think that, and so in Africa, for example, there's a big push now to develop drought-tolerant seeds, and those could have all sorts of benefits. But when people talk about things like drought-tolerant seeds or heat-tolerant seeds, they're talking about cutting the losses by a few percent. They're not talking about something that can all of a sudden not have the basic constraints of what crops have. So I think that the Gates Foundation can be rightly criticized. Are we taping this or okay? So they could be rightly criticized for having historically been a bit too simplistic in how they approach things. I think most people kind of at the forefront of agricultural research globally will look at sort of combinations of factors to be implemented. Seeds are definitely one of them, but something that Marshall works a lot on is how do you get the financing right? How do you get the risk management right so that they can actually make those investments and make other investments? And the soil improvement is really, it's such a heterogeneous issue that what works in one area won't work in another area, or it might work, but it won't be cost effective. So these are the kind of things our center struggles with. And it is, again, back to the communication. I think what the Gates Foundation, for better or worse, tries to balance is that they want a really clear message getting out there. So they have these nice 1-minute videos of Bill Gates, having a pile of, you guys should go watch the Gates annual letter. Now it's like instead of a letter, it's just a video, and he just says, we have a lot of corn in the U.S., we have a little corn here, we just need to move what we have here over here. And he's much smarter than that, but part of the communication is to just try to simplify things.
Yeah, right. But you make a really good point, I think, about the importance of social capital in this. We tend to think, well, we're working on the farm, in the soil, developing new seeds or whatever to try to increase resilience, reduce vulnerability. but it's getting all of the social infrastructure right to allow that to happen. And to allow farmers with great ideas to actually begin, to go after that stuff. So great points. Now, I could go on with these guys, but I'm going to turn to you for questions. So please, go ahead.
What are the top challenges that the state of California or nationally would have to stop the massive subsidies going to Monsanto's and whoever else for corn and soybean and whatever, and subsidizing the livestock industry, especially cattle and the Burger Kings, and we're still having the $3 burger that we've had for about 25 years. We had a huge drought, as we all know. What's going on the legislative front? What are the opportunities for us as citizens to move that small area forward?
There's opportunities as citizens too, in terms of what we buy and what we eat personally, right? But so I think the question was, are there policies that are driving these things in one direction or another?
Well,
Go ahead.
I mean, David might have more of a direct Farm Bill related response, and I don't know if that were you going to talk about the Farm Bill?
Yeah, I was just going to save Eli the responsibility of responding. So, but go ahead.
Okay. But,
Go ahead.
I mean, I would just say that, well, there's the federal legislation which has been partly responsible for, subsidies to maybe stakeholders in the food system that aren't necessarily aligned with the kinds of broader social and ecological goals that we are discussing. And so if part of the solution is more localized, part of the solution, I'm not saying, trade is a no-no. We definitely, I actually really love chocolate and coffee and bananas, and I'm going to still eat them and drink my coffee. But I think we can manage those global trade in more healthful ways as well. But as far as the kinds of business interests that are being supported by our tax dollars, I completely agree, and we need to do everything we can to kind of reverse or change the policies. And unfortunately, it's like every 5 years that the Farm Bill gets debated and discussed and modified. So there's the National Sustainable Agriculture Coalition, and SAC is a great resource for kind of monitoring federal Farm Bill engagement if you're concerned similarly. And then one idea that I just want to put out there that we're beginning to discuss here locally for San Mateo County would be a local Farm Bill. So just start to say, okay, well, if the federal legislation is too difficult to make the kinds of changes that we want, if we had our druthers, what kind of policy would we want to create that would reflect the values that we're talking about here? So if you're interested in being involved in that, just let me know. And I know Matt Roth from the Feed Collaborative here at the D School at Stanford's interested in that. There's going to be a student working on it this next quarter and over the summer. And then with the San Mateo Food Systems Alliance, we also have a group who's beginning to look at this question. So a local farm bill.
Great. Anybody else want to comment on the?
Well, I guess what I was going to say is, you won't find a country in the world where food isn't a political issue and where there aren't political interests. And there's, arguably some role for the government in stabilizing farmer welfare and things like that. But what's happened over the last decade or so, which has been really interesting in the U.S., is that a lot of the forms of farmer support have shifted from some forms to other forms, and in particular, the biggest increase has been in subsidizing insurance premiums. Now, that's been really good for businesses that are in the insurance area, but one of the things it seems to have done is kind of not surprisingly encouraged more risk-taking by farmers. And so what we see is, in the research we've done, we see that the impacts of drought have not been getting lower over time as seeds have been getting better. They've actually been, if anything, going up over time. And it can be partly explained by sort of rational responses to more subsidized insurance. So there's this kind of conventional wisdom out there, which is that rich countries will be able to adapt more readily than poor countries that have less capacity. Well, if rich countries have risk-encouraging policies, that's not necessarily true. And I think there's some, if the current system were to stay in place, there's some argument that a lot of the impacts of climate change will really be borne by the taxpayers as opposed to food producers or consumers.
Oh, that's really interesting. It's like we're moving away from subsidizing flood insurance for residential homeowners. If they're going to do it, they take the risk themselves, right?
Right.
But we're going in the other direction, it sounds like, in agricultural systems. Interesting. Okay, yes, sir. Go ahead.
Do you think there's a place for animal agriculture in any large-scale way in a future sustainable system?
Role for animal agriculture in a future sustainable system.
I definitely have a response to that, but I've also been responding to the last couple questions. I don't know if anyone else wants to.
Go ahead, and we'll see if we can get a debate
Well,
going here.
I'll say yes, but
So, yeah. Very much so. In fact, our system that we're working on, that we want to be testing and sharing, if the results are as good as they appear to be from our 10 years of practice, is the integration of intensively managed pasture-based animal agriculture systems in concert with intensive tillage. So it's sort of responding to the, realities of small-scale diversified holders and world over, this kind of blending of cultivation with longer periods of rest for ground and soil building, we feel is really part of a strong potential for the solution. I'll say on our small acreage that we've been doing this on for the last 10 years, we've seen some of our fields that we have in this cycle go from like 3.5% organic matter, which is actually pretty good for soils in general, to on some of our fields over 8%. And over this 10-year period, we do 4 years as intensive vegetable production, and then 4 years as intensive vegetable production, and then 4 years as thick, densely covered soil and pasture. That we have cows that graze, and then we follow the cows with the chickens. And so across the street, we've just been, this last year, developing a scaled-up version of that. So we have about 33 acres in pasture that the cattle from Tomcat Ranch in Pescadero is running on that. And we have Early Bird Ranch. We just bought the flock of Early Bird Ranch layers that follow that cattle. That we're going to run for 4 years. And on a similar size plot to the south of that field, we're doing the intensive organically managed row crop system. And we're getting we have minimal baseline data on soils. That's where the invitation people are interested in on the research side of this is to understand the system. But you get an incredible amount of protein on the animal side, as well as carbon building through the sloughing off of the roots when you have a pasture system that ruminants and birds, when they pick the grasses or legumes at the top, then kind of an equivalent of root matter sloughs off and becomes available for the life in the soil to do its work of making that carbon more stable in the ground. So our big question about this, though, is after we go back into tillage, or the big question that people ask us, especially those who are advocates of no-till, is aren't you just then burning up that organic matter once you go back into your row crops? And we've seen, this is why we're wanting to do it, replicate it on a larger scale, is we've seen it does go down, but then because there's overall a net increase over the duration of the period. So anyway, animals, we started out wanting just to have the animals, all the different kinds of proteins that we eat on a regular basis, or those who eat animals, know what it's like to slaughter a chicken and have that the realities of meat consumption be present to the high school students and adults that we work with. And we wanted that cows because we wanted to be able to make butter for our pie crust, But now we realize that the cows have a real meaningful role to play in maintaining that health of the soil. And so, if managed in this way, we think animals have a really critical and healthful component to maintaining a good food system.
You're talking about a very complicated, integrated system. It actually would be really fun to study, for sure. But it does raise challenges for, expanding that kind of management strategy to any, around the world or the country, because it is really complicated, right? You need to know all those things. So knowledge intensive. Great example. Anybody else have a response to that question, or we'll move on?
From a sort of developing world perspective, I mean, anyone who's traveled in the developing world knows that sort of livestock are a fundamental part of rural life in most parts of the world. So, whether we like it or not, livestock are around to stay. But I think what economists have shown is a lot of the livestock, it turns out, are actually, or might be, a substitute for one of the problems that David brought up, which is a lack of financial institutions. So people keep livestock as what economists call a buffer stock, basically a savings account, right? This is something that is going to stick around. Hopefully, it won't wander off if you've built your fence well. And so in the absence of other ways to save, people put their money into cattle or into goats or something. And I think an interesting question, and maybe one we don't have a great answer to, but we could sort of intuit about. So if we were to expand financial access around the developing world, would we see a pretty large drop in livestock holdings? And my sense is that in many parts of the world, you certainly would. So to the extent that, we think that there are a lot of livestock around, that these are causing some problems we don't like, this could have a sort of unintended but large benefit.
I'll just add to that conversation before we go on to the next question that you also have to think about livestock animal protein from a human health perspective, and it is absolutely true that in the poorest countries of the world, a little bit of protein makes a huge difference to human well-being. A little bit of eggs and milk can make all the difference in the world in terms of development, mental development of children and so forth. On the other hand, maybe we have kind of overdone it here. So we can go on and on about that question, but let's go on to the next question. Did you have one? Yes.
Yeah, question for Jared. Just as an aside, I'm a huge admirer of High Ranch and all the work that you guys do. So you mentioned innovations and tools to help farmers implement more climate-friendly practices and improve soil. I know that there's a lot of Stanford students, whether they're in the engineering department, the business school, other disciplines, who really want to help out with this. And so where should we best direct our energies right now? What is, in your view, the most needed innovations and tools for farmers?
I felt like I had a good response until you got to that last part of the question, the most needed. I'm not sure if I can, understanding if there are tools that can be developed kind of in a way that Eli's doing it from sort of the macro satellite-based perspective on managing nutrient and understanding weather, being able to respond effectively. There's some, kind of as David was saying, so much of the decisions are very site-based. And for us to be making decisions about what crops in our system that we want to be growing and can grow, being able to respond, being able to manage soil and carbon and crops effectively, it would be great to have more tools that get more quickly at understanding the soil that's beneath our feet and that we're working with. So, if there was something I can plug into my device and I'm out in the field and I can just point it to the ground, or Google how it comes up with soil view instead of street view, and if there's other tools that help us understand the complexity of the life that's in the soil and how to best work with that, or understand the responses to the decisions that we make. If tillage in the wrong moment could lead to years of repair of that soil. So tools that help us understand the biotic life that we're responsible in our stewardship would be great. I think that, and all of it's, whether it's water, soil, air, that are appropriately and affordably available to the small, mid-scale farmers around the world. The other one idea that I wanted to mention was on this large scaling up of the intensive pasture system, we would love to take advantage of some existing technologies like these rolling irrigation systems, but innovate off of them, like a tinker toy kind of setup where we can hang the mobile electric fencing to hold our animals in the space that we want them to be in, so they create the least damage on the pasture for the short period of time. So we're moving them rapidly. At least once a day, the animals are moving. And it's a lot to have to pull up. We have movable fencing right now, and it's stake-based. You put the stakes in the ground, and you have to pull them all up and move it around. It's when you're scaled up version, it takes a long time. So if we can set it up so that it's a hanging curtain.
It's a nice invention waiting to be made.
Yes, so if there are engineers who want to help us with that, we would love it.
That's great. Maybe there will be. I know that David and Eli and Anna all, in one way or the other, have developed remote sensing approaches to understanding what's going on the soil and surface of the planet and water systems and so forth. Do any of you have anything else to add, Eli? It looks like maybe you.
Well, just to talk briefly about one of the products that we're actually building right now, which is what we call a nitrogen advisor. And so, we're mostly focused today on corn farmers, which has the associated challenges that have come up in this meeting. But if you look at corn farmers, one of the biggest negative environmental impacts of corn farming is that farmers tend to dramatically over-apply nitrogen, and it floats down whatever river is nearest, and it ends up in a lot of the impacts that Anna was talking about. And a big reason why folks over-apply is because they don't know exactly how much to apply. And so it's good risk management, in their view, to apply more and not lose yield, because it's more expensive for them to lose yield than slightly over-apply nitrogen. So, one of the tools that we're working on right now is a tool that, so farmers periodically test their soil and evaluate, the quantity of different nutrients in that soil. But one of the problems is, say, for example, you planted your corn crop a month ago, it's probably not going to be possible to get out there and test the soil and see, is this going to have enough nitrogen after that series of big rainstorms, for example, like some of the big rainstorms we had last April across the Midwest. And so, the nitrogen advisor, what it tries to do is understand, based on the most recent access to data from a farmer soil test and an understanding of crop nitrogen use, an understanding of how that soil reacts to rainfall and ways in which nitrogen might be lost to runoff, and give that farmer a much better insight and recommendation into how much nitrogen is left in that soil, so that rather than just having to guess and throw as much on there as they can just not know perfectly, but have a pretty clear sense of how much nitrogen is there, and have the confidence to apply less, and which, by the way, does save them money, so farmers get excited about it, but also makes a significant environmental difference, if farmers are willing to adopt that, because it doesn't all flow down the river. And so I think that there's a huge amount of work to do in that area, particularly around figuring out how do we make that sort of software available outside of the sort of corn monoculture row crop space, but it's happening, and it's an incredibly exciting area. So
Thank you.
I think it's cool.
Just real quick, and then we'll ask for one more question. So go ahead, Anna, really quick.
So a little bit different from what Eli was talking about, but Jared has been talking a lot about how do we manage ag in a way that makes us good stewards of the soil that we ultimately rely on. But getting back to that topic, and one of the questions was asked before about animal husbandry, there's also the other directionality. So how is ag then contributing to climate change rather than just being impacted by climate change? And I think that's where a lot of work is needed as well. And so, for example, some of the things we're finding is that if you look at inventories of emissions, they don't add up to the amount of greenhouse gases we're actually measuring in the atmosphere. So how do we actually understand how raising ruminants and manure management and soil conservation, or lack thereof, are actually impacting the amount of greenhouse gases in the atmosphere, and therefore impacting climate in turn? And that's where large-scale monitoring, whether through satellites or aircraft or tall towers or whatever it may be, goes hand in hand, because it turns out that even at a macro scale, the sum of the parts of what we think is going into the climate system does not equal what the atmosphere actually sees as the sum total. And so I think it's important to understand it's a two-way street, in that climate is impacting ag, but very much ag is at the same time impacting climate, not only through land use, but through both carbon dioxide, methane, and other greenhouse gas emissions.
Great, thank you, very good. We have time for one more question. It's going to have to be really quick, and then we'll wrap it up. Yes, go ahead.
So my question could be for everyone. It's more in Marshall Burke's area of expertise, though. With those very substantial sensitivities of agricultural output in the developing world and increases in conflict to minor rises in temperature, perhaps we're already seeing it, or you might be very concerned about it happening in the near future. Are we seeing meaningful parts of the developing world falling back into the Malthusian trap, where wages for unskilled labor fall to just enough food to sustain a family of four? And if we are seeing that misery reemerge, what would be a straightforward way to avoid it?
And Marshall, you've got about 30 seconds to answer that.
Straightforward is tough, so I won't touch that one. No, I don't think we've fallen into a Malthusian trap yet, for sure. In the past decade, we've actually seen a lot of economic growth in parts of the world where we haven't seen it for the decades before that. So Africa has actually done pretty well. Not necessarily in agriculture for reasons outside of agriculture, but sort of on average, Africa has done better. So we're not there yet. Our results suggest if you run the world forward, if you believe these sort of historical responses, things definitely could get worse. And what they also suggest is that sort of investing in agricultural adaptation would be one way to sort of break this cycle. So some of the sort of investment options that we've talked about already, we think are a promising way to start, both to address the potential problems in agriculture and to maybe address these more broad societal problems.
Great. Well, thank you so much. Now, I am sorry that we have to draw this to a close because there's a class that's coming in here in just a few minutes. So I will ask you as we leave, why don't you head out that way? Maybe some of the speakers can hang around and answer a few more questions if they have time. But before you all walk out the door, please join me in thanking this wonderful panel. Thank you.